everybody. Happy new semester. We are going to begin Unit 4, which is all about rational expressions. We're going to jump ahead to 4.3 and then come back to 4.2 later. This is going to be about multiplying and dividing rational expressions. There's a lot more factoring in this unit also, so that factoring continues to thread itself through the entire year. Okay, so today we're going to focus on simplifying radical expressions and multiplying. All right, so first of all, what is a radical expression? It's an expression that is a fraction of the form p over q, where p and q are both monomials or polynomials of some form. So these are all examples of rational expressions. They're in fraction form. Each fraction has some sort of monomial or polynomial of some form, and so these are all rational expressions. Okay, so simplifying rational expressions, it's basically writing an equivalent expression. Okay, so rational expressions can be simplified in a process that is similar to the process of simplifying rational numbers. So just like we're using numbers. So we take 12/16. 12 has factors of 3 times 2 times 2, right? That's the same thing as 12. 16 is the same thing as 2 times 2 times 2 times 2. So you write them out in factored form. Then we can take and cancel out the 2's, and we're left with on the top 3 over 2 times 2 is 4. So 12/16 is equivalent to 3/4. And we also say that that's simplified as well. Okay, we're going to do the similar thing with rational expressions. We get it in factored form, just like we did up here. And then we find common factors. Remember, factors means you're being multiplied together. Okay, not added, not subtracted, multiplied together. And so once these are multiplied together, like these two are here, we can cancel common factors, and leaving us with a fraction of x plus 4 over x minus 3. Okay, that's very important to understand what you can cancel and what you cannot. Okay, I cannot take x plus 4 over x and cancel those x's because x and 4 are not factors. Those are sums. So this would be simplified already because I can't cancel those x's. They are not factors. Okay, so please watch out for that. Be aware. So let's simplify this rational expression. The very first thing we're going to do is factor the polynomials on the top and the bottom. Okay, that's the very first step we take. So the very top, we're going to always again look for that GCF. So I'm going to factor an x out on top. Leaves me with x times x squared minus 5x minus 24. I'm also going to factor an x out on the bottom. X here leaves me with an x squared plus x, and then minus 72. Okay, now I'm going to continue to factor this trinomial right here. Factors of negative 24 that add up to my negative 5 are going to be negative 8 and a positive 3. That should be a 8, and that's a 3. It's not writing very good. Okay, so I'm going to factor that out some more. Then the top is going to be x times x minus 8 times x plus 3. Okay, divided by the bottom one. I want to find out what are factors of negative 72 that add up to 1. In that case, it's going to be, we got negative, let's say positive 9, negative 8. Okay, so we're going to factor that one out. X plus 9, x minus 8. So now these are all written as factors, right? X times this, this times that. These are all multiplication, all factors. Okay, now right here, we want to know any restrictions right now. So what is a restriction? A restriction is something that if anytime I divide by 0, that's a problem because you cannot divide by 0. So right here, this is similar to finding zeros of a polynomial, but it's a little bit different. Kind of. So what would make this 0 right here would be 9, right? If x was a 9, 9 minus 0, or excuse me, 9 minus 9 would be 0. And 0 times anything is 0, and we need to divide it by 0. So my x cannot be equal to a 9. Okay, right here. My x can also not be equal to a negative 9, right? Because if I put negative 9 plus 9 would be 0, and 0 times all that bottom would make it a 0, right? X can also not be equal to 0 itself, because right there, if I plugged in 0, 0 times all that would be a 0, and we'd be divided by 0. Okay, so right there, we have to make sure we notice any restrictions in my domain. Okay, these are restrictions in my domain. This pen is not writing very good lately. I don't know what's the deal. Okay, my restrictions in my domain. Okay. From here now, we can start canceling our common factors. So I have an x right here I can cancel out. Okay. And that's, oh, it looks like I put an 8 there where the 9 is supposed to be. Why didn't you guys tell me that? Okay. So then I have an x minus 8 and x minus 8. I can cancel those guys out because x minus 8 divided by x minus 8 is 1, right? Okay. I'm going to write what's left over. On top, x minus 3, or x plus 3, over x plus 9. And then I write my restrictions. My domain, my x cannot be equal to 0 or positive and negative 9. Okay, and there we go. Okay, so my equivalent expression is x plus 3 over x plus 9. And then that is my restriction on my domain, okay, because I have undefined moments at 0, negative 9, and 9. Okay, so that's how I simplify a radical expression. So let's go over here. Let's take a look at some more. What is a simplified form of this one? Now this is kind of tricky because notice my number here is first, 4 minus x squared. When that happens, we want to factor out a negative here. Okay, so I'm going to actually factor out a negative, and that's going to make it a negative 4 plus x squared, right? Because 4 divided by negative 1 is a negative 4, and negative x squared divided by negative 1 is positive x squared. I'm going to go ahead and factor out the bottom right here too. Factors of negative 10 add up to 3. Factors of negative 10 add up to negative 3 are going to be a 5 and a negative 2. Oh, sorry, positive 3. My bad. Yeah, I'm getting late tonight. X plus 5 times x minus 2. And I'm going to go ahead and come down here. I'm going to flip this around now so it says x squared minus 4. X plus 5 times x minus 2. And now this guy is a difference of 2 squares. So now I can write negative and factor that to x plus 2, x minus 2 over x plus 5, x minus 2. Okay, now I'm all factored. Now I want to make sure I note any restrictions on my variables right now. So I'm going to put right here, x cannot be equal to a negative 5 right here. Okay, and x cannot be equal to a positive 2. So I want to make sure I pay attention to that, okay? Then I'm going to go ahead and cancel my common factors. Negative x minus 2, x minus 2. So what I have left over now is going to be opposite of, oops, I changed my color. Opposite of x plus 2 over x plus 5. And x cannot be equal to negative 5 or 2. Now, some might argue that this is going to be simplified to negative x minus 2, okay, over x plus 5. And so just be aware of that, okay? All right, so that is simplifying my rational expressions. All right, let's do one more here. This one on top here looks like it's a polynomial with 4 terms. And so I'm going to factor by grouping on this guy, okay? So I'm going to look right here. I'm going to factor out an x squared term. That's going to leave me with an x plus 4. Then I'm going to factor out a negative 1 over here, and that will leave me with a positive x plus 4. On the bottom here, factors of negative 4 that add up to 3 are going to be x plus 4, x minus 1. Everybody's okay with that? Then up top here, I have x plus 4, and the leftovers are going to be this x squared minus 1. So hopefully by now you're really, really comfortable with factoring. If you're struggling with factoring, you might need to come pop into Zoom with me and get some help because you cannot afford, again, to be bad at factoring in this class, okay? So then we're going to continue factoring x plus 4, and this right here is a difference of 2 squares, right? So we're going to factor that to x plus 1, x minus 1 over x plus 4 times x minus 1. Now everything is a factor, okay? Everything's multiplied together. So now I can cancel common factors. Actually, first what we should do is write our restrictions, okay? So right here, x cannot be equal to negative 4 and positive 1. Okay, -4 and +1. Now I can cancel out all my common factors, x minus 1, x minus 1, x plus 4, and all I am left with now is my x plus 1, and x cannot be equal to -4 or 1. Okay? All right. So now we're going to go ahead and start to multiply. There's really nothing any different here because when you're multiplying rational expressions, they're just factors. Okay, and we're going to just simplify with those factors as well. Okay, when you multiply fractions, you multiply top times top, bottom times bottom. Okay, and so right here we have just 2, or I should say 2, not 3, 2xy over z times 3x squared over 4yz. Now you can simplify right here, or you can multiply and then simplify. I like to simplify first because then it doesn't make things really big and nasty and out of control. Okay, so I look for common factors on top and bottom because these are all multiplied. This times this, and that's multiplied, and that's times that, and everything's multiplied, so we can cancel out factors. Okay, so our y cancels with our y. Our 2 goes into 4 twice, and that's it, right? The z's are both on the bottom, so we can't cancel those. You can only cancel top and bottom, not top and top, right? So this is going to be on top, we have 3, and x times x squared is x cubed. We have a 2 down below here, and then a z times z is going to be z squared. And there we go. Okay. And if we want to get technical with this particular one, yes, y cannot be equal to 0, and z cannot be equal to 0 as well. Okay, because that would make my denominator 0. Okay, all right, so now let's multiply this guy. This looks kind of ugly, right? We don't have just one to simplify, we have a bunch. Same thing happens. We just factor every one of those guys, find our restrictions, and then simplify, okay? So I'm gonna have my 5x on here over x plus 3. That's already factored. And remember, this is a factor right here. Sometimes it helps to put parentheses around it so you don't try to cancel this x with that x. These are not factors, these are sums. So watch out for that, okay? Factors of -6 add up to 1. Be careful with those factors. Lots of people want to put 5 and 1 there and all kinds of crazy stuff, okay? So this is going to be x plus 3, x minus 2. Check yourself if you have to. 3 times -2 is -6. 3 plus -2 is 1, so that works out. X squared, so factors of 1 that add up to 2, of course, are going to be x plus 1 times x plus 1. It's a perfect square trinomial. Right here, I just have it's a binomial, so that should raise your eyebrows. Just factor a greatest common factor out of x, so x times x plus 1. And then factor a 5 out on the bottom, x times x minus 2. Okay, now everything is a factor, right? 5x times x plus 3 times x minus 2 times x plus 1. X plus 3 times x plus 1 times x plus 1 times 5 times x minus 2. So everything's factors. We want to identify our restrictions right now. So x cannot be equal to, over here, -3. Okay, that one's -3. This one, I cannot be both of these, so it's -1. I only have to put it once, I don't need to put it twice. Okay. Right here, and it cannot be equal to 2. So those are my restrictions right there. Okay. So these are going to be my restrictions on my final expression. So now I can go ahead and start canceling out my factors, my common factors. So I have an x plus 3 with another x plus 3 up top. I have an x plus 1 over here with x plus 1 on the bottom, an x minus 2 and x minus 2. I have a 5 over here with a 5. I can't cancel these x's because they're both on top. Okay, and so I think that's everything. So everything on top, we just multiply top times top. So x times x is going to be x squared. Over, and multiply out the bottom, I just have 1 left, is going to be x plus 1. And that's it. With x cannot be equal to, that's supposed to be a lot, there we go, -3, -1, and 2. And there we go. Bada boom, bada bang. Okay, so it's just a matter of factoring everything out, identifying your restrictions, and then simplifying. Okay, All right, we got one more to go, and then I'll cut you loose here, okay? So we have x plus 2, and then we're going to simplify this. X squared minus 16 is going to be, or x to the fourth minus 16. So the square root of x to the fourth is x squared, minus the square root of 16 is 4. That's a difference of 2 squares, so it's going to be x squared minus 4, x squared plus 4. So watch out for those. Okay, so we're multiplying. It says, what's the product of those two? So that's multiplying. And then I'm going to take a GCF out of here. So x, I'll be left with x squared plus 4x minus 12 all over 1. We want to write it as a ratio. Okay, so when there's not a complete ratio there, it's still over 1. So what's the product of those two? We kind of factored as I went. So now I have x plus 2 over. Now this one right here, this is a difference of 2 squares. So I can factor that one. X plus 2, x minus 2. This one is not. This is a sum of 2 squares, so I cannot factor that guy. That has to stay as put, okay, as is. This one, factors of negative 12 to add up to 4. That will be 6 and 2. So that will be x plus 6, x minus 2, and then all over 1, okay? Let's identify our restrictions. So x cannot be equal to, we got negative 2. We have a positive 2. And this one's kind of tricky, right? So if we have to find out what that one is going to be, what we have to kind of do is I'm going to come up here and go, when does x squared plus 4 equals 0? When does that happen? Okay, so actually I'm gonna make this red. No, and so I already have a red, don't I? Let's make this one pink. Okay, so I'm going to subtract 4. So x squared equals negative 4. If I square root both sides, okay, this doesn't really matter because it's going to be imaginary number. So there's no really restrictions for real numbers on x squared plus 4. There's nothing I'm going to substitute in there that's going to give me a 0 that's a real number. Okay, they're all imaginary numbers. So we don't have to worry about that one. Okay, so we're going to now cancel everything. Okay, so we have x plus 2, x plus 2. We have an x minus 2, x minus 2. And I think that is it. So we're going to go just x times x plus 6 over x squared plus 4. And x cannot be equal to negative 2 or 2. I'll give you a little bit of a warning. In the Excels, they might have you simplify the top, meaning they might have you write x squared plus 6x. They should give it to you in the description for the answers, so make sure you read those carefully, okay? Usually on the bottom, we leave them factored, and on the top, sometimes we simplify those, so watch out for that, okay? Okay, so you do have an Excel in Google Classroom. Do that. Be sure to attach all your work and answers. There's no more blank works are not applicable and so forth. You need to leave an answer or work for every single problem and have that attached in order to get your score. Okay? Have a great day, and I will see you guys in Zoom. I hope you have a good start to the semester. Bye-bye.